This portion of the recording is to help you with the always, sometimes, never portion. On your test, you will have one column that you're selecting your always, sometimes, never. Then on the middle part will give you your statement, and then on the third column, it's required that you write a picture that shows what it is that the reasoning behind your always, sometimes, never choice. All right, concentric circles are congruent. So I would say that this is never. And the reason that I'm choosing never is because concentric circles need to be distinct from each other, so they should not have the same radius. So if concentric circles, it means two circles that have the same center, they cannot be congruent and be distinct from each other. So then the next one, congruent circles are concentric. Well, that goes back to the same one. Concentric circles can't have the same radius, so they can't be congruent. So again, that's never. In a circle, if a diameter is parallel to a chord, so here's my diameter, and here's a chord, and I know that they're parallel, then it bisects the chord and its arc. Well, there's no way for it to even intersect it, much less bisect it. So again, this would be never. Now, just to clarify, if I had a circle with a diameter and they were perpendicular, not parallel, then that would be the case. Okay, but they would need to be perpendicular, not parallel. Up here, I did not draw my figure, so I'll go back and do that. So these do not have the same radius. This would be a radius of x, and this would be a radius of x plus y. So it would be different, and they would not be congruent. All right, if an intercepted arc of an inscribed angle is a semicircle, so here's my inscribed angle, that's a semicircle, then the angle is a right angle. And because this is 180 and inscribed angles are 1/2 their intercepted arc, that would be always. If a quadrilateral is inscribed in a circle, so here's my quadrilateral inscribed in my circle, then its opposite angles are complementary. They're opposite angles in a quadrilateral, if it's inscribed in a circle, are actually supplementary, not complementary. So that would be never. A chord that bisects a diameter is congruent to the diameter. So here is a diameter, and I have another chord that bisects it. So if it bisects it, it's going to, and it's a chord, it's going to also have to be a diameter. So that would be always. A tangent to a circle contains the diameter. So if I have a tangent to the circle, and here's a diameter, the only thing they share is that point, and that's not containing the whole diameter, so never. If a central angle and an inscribed angle intercept the same arc, so here's going to be my arc, and here's my central angle. Central angles, the vertex is on the center of the circle, and an inscribed angle intercept that same arc. So here will be my inscribed angle, a little bit crooked. Then the angles are congruent. The angles will never be congruent because let's say that this is a 60-degree arc, then that means this central angle is 60, but it means the inscribed angle is 1/2 that, so it's 30. If two circles are congruent, then their diameters are congruent. That would be always. So if the diameter here, that's really the only thing that differentiates our circles. If the diameter of a circle bisects an inscribed angle, so here's the diameter, and it's going to bisect this angle. Then it bisects the angle's intercepted arc. That would be true. So we know that this, let's just make up something. Let's say that this is 100 degrees. Then I know this is 50. Well, if it bisects it, it's 25, 25 for each angle. So this is double, so 50, 50. So that's always. All right, the next section, the next video, will work through some of the problems that are in your packet.